Okay, we're starting at A. If you start at A, where do you end up?
B. Yep.
With these vectors? No.
No, you end up at E.
You end up at E. So this is the simplification of this.
You don't know your alphabet.
Because according to this, you go from A to B. B, you go to C. C, you go to D. And D, you go to E. So that's the same as starting at A and ending at E.
So that's not collinear.
Not necessarily collinear.
Well, yeah, that picture.
Now this one was pretty straightforward because it started with A. When we look at this next one, we've got a whole bunch of expressions. We need to see what we can put together and what we can't, and what we're going to end up with. Yeah, there's a common factor of 2. You could factor that all out so that you could multiply that after if you wanted to. Sure. Oops, that'd be 2. So you took out a 2 because there was a common factor of 2. Any of the things in here that you could put together?
Yes.
What can you put together?
C, D, and CD.
There's a CD and a...
So you minus.
That's right. So the CD... So this one, the CD and the DC could be put together by minusing? Any other ones that you could put together that way?
All of those can go into 3.
The AB, the AB and the 2 BAs could be put together? Okay, so let's, and still have a 2 out in front. If I put these together, do you see that I would be left with a BA? 2AC. Plus, if I put those together, I'm going to be left with 2 CDs. And I still have a DA. Anything else you can see? Anything else you could put together? You can put the AC and the CD together. Because AC and CD is the same as going from A to D. So 2 ACs plus 2 CDs.
So you don't need the letter in between.
Well, they are. They have a C in,
Okay.
right? The C is in common. So you're going from A to C, and then from C to D. That's going from A to D. So then you got 2. We've still got our BA. These 2 together are going to be 2 A to Ds. Anything you can put together here?
Yeah, you can change that DNA around.
The DA and the AD will just give you 1 AD. Oh, this question's bad. Because you got 2 DAs and 1,
I see that.
2 ADs and 1 DA.
I think we're done. No, wait.
And then this becomes
No, we can go from BD to D.
2 BDs. And now it's simplified. Nice. That was a lot of fun. All right, we have one more question before the homework. Let's get it done.
I don't know if you got time, Jared. This is a 4-part question.
All right, I've got it pre-done just in case we got to this specific. You got a rectangle, let's draw a rectangle. Here's our rectangle. O to A is A, O to C is B. It's kind of screwy lettering because you'd think O to B would be B, but no. Express the two diagonals. So one diagonal is A to C. Well, you could get there by going negative A plus B. And the other diagonal is from O to B, which is A plus B. And we know that this length here is 8. Put that on my diagonal. And this length here is 6. So as far as, if you think of these as points, the point B would be 6 to the right and 8 up. Obviously, my rectangle is drawn to scale, as everything always is in this class. Does it make sense that the vector A could be written as 0, 8 and the vector B as 6, 0? I skipped B. So, yeah, question B just asks for the length of O to B. Well, we figured out that O to B is 6, 8, and then you just have to do 6 squared plus 8 squared. All right. Wait for Kyle. Scroll down for Kyle. That's B at the bottom.
Kyle's good.
You're done. Okay, everybody ready for C? So part C says find the length of OB plus CA. Well, we know that OB is A plus B. And we knew that CA was, or we knew that AC was negative A plus B. So if you did C to A, that would just be a negative in front. Simplify that, and you just get to A. The length of A was just going up 8 units. So the length of the whole thing would be 16. And the answer, well, does it make sense? You go from A to O, O to A, A to C, and then you're back at O again. So you would be back at 0. So here is exercise 13B.